Right. I am recording this lesson. You are supposed to be doing this kind of on your own, but I am going to record the part that I would go over with you together as a class. So today is Unit 4, Lesson 3, Graphing and Transforming Square Root Functions. And our objectives are to identify the features of a square root function and use transformations to write equation of a square root function. So the parent function, remember, is the simplest version of a function. So the parent function of a linear would be y equals x, and for quadratic, it's y equals x squared. So for the parent function for a square root function, it is the square root of x. Remember, if there is no number in the index, we assume that it is a 2. So because we cannot take the square root of a negative number, the domain of a square root function is limited to 0 and positive numbers. Notice here to the left starts at 0, 0. That's my y-intercept. And it's also my x-intercept. The range, if I go up, it also starts at 0, 0 and goes to infinity. The end behavior as x is going further and further to the right. Y is going up, so it's also increasing. And as x is going towards negative infinity, then the y is going towards 0. And as a matter of fact, x is also approaching 0. Excuse me. And if you'll notice some key points right here, this is 1, 1. Has a square root of 1 is 1. 4, 2. Square root of 4 is 2. And 9, 3. Square root of 9 is 3. So this is kind of like the inverse of x squared, but it's, remember, the x squared we can have all real numbers because we can have negative numbers as well. One of the things that I want to point out is the a of this, or the starting amount, is 1. Just like quadratic, if I go from the vertex and I go over 1, I'm also going up 1. Okay. Your job, while I'm gone, is to put these into your calculator, into the Desmos graphing calculator. Type it in. I want you to put this first one in your equation 1 and leave it there. And then take turns putting the next ones into the equation 2. I want you to write down what happens to it. Some of you may have already figured out what's going to happen to it. As you finish this, make sure that you are taking notes, and then you can summarize it. I've gone ahead and summarized it here in case you get confused. Okay, so the negative a, just like with quadratic, reflects it across the x-axis. If a is greater than 1, it's a vertical stretch. If a is a fraction, it is a vertical compression. minus h shifts it to the right. X plus h shifts it to the left. Remember, opposite inside. And then plus k shifts it up, minus k shifts it down. Same outside. These will change the domain and range because it's going to move the whole graph. So as it moves that vertex in the graph, it's going to change the end behavior and the domain and range. All right. This guided practice, these first two, are just using the words. We have an equation of a square root function that has been reflected across the x-axis. That means that my a is going to be -1. It is shifted seven units to the right. So that means that my h is 7. And it's been shifted 5 units up. So my k is 5. H and k. I have everything I need to write my equation. My a goes in front. My h goes inside, and it's going to be the opposite, so it's going to be -7. And then my k hangs out at the back end. Now you may see some of these where they take that k and they put it in front. So if you ever see it written like this, it is the same thing. Sometimes they don't want you to get confused and think that that +5 is inside the square root. All right, so this next one, I want you to try before, so pause the video and see if you can do the next one on your own before you do it with me. Okay, so this one has been stretched vertically by a factor of 2. So that means my a is a 2. It doesn't say anything about being reflected, so it's still going to be a +2. It's been shifted 4 units left, so my h equals -4. And it's been shifted 3 units down, so this would be -3. I have everything I need to write my equation. My a is 2, and then my h is -4, so minus a negative is going to be +4, opposite inside, -3, same outside. Okay, when we are writing it from a graph, we're going to do the same steps. We're going to determine the value of our h and k by finding our vertex. And remember, it's going to be opposite inside, same outside. Then we're going to determine the value of a by using the idea of that parent function goes 1 to the right and 1 up. And so when I go 1 to the right, the difference in my y value is going to be my a. And I have to remember, if it is reflected, it is going to be negative. And then a good way to check it would be to plug it back into your Desmos graphing calculator and make sure that it matches. Okay, so this first one I've done for you. We have the vertex at -5, -4. So my H is -5. Oops, wrong color. H is -5. And my K is -4. All right, if I go from -5 to the right, that's going to be at -4. And when I go up on my graph, that is adding 2. And I can look at it here as well, going from -5 to -4, the x's, and then -4, -2 is the point to the right. So the change in the y is +2. So that is going to be my A. So my 2 opposite of -5 and the same on the outside. Okay, last 2. I've given you the vertex on this one. It is -5, 0. And then the point to the right is -4 and -1/2. So this one is actually going down. 0 to -0.5 is -0.5. And I can write it as -0.5, or I can write it as 1/2. My H is -5, and my K is 0. Plug everything into my equation. -1/2 x minus -5 would be, get this, +5. And then +0 doesn't change anything, so I'm not going to put that at the back end. Okay, this last one I want you to try on your own before you watch the video. So just pause the video and try it. Okay, my vertex is at 0, 4. And then if I go to one to the right, that's going to be 1, and it's going to be 1. So going from 4 to 1, I'm going down 3. So my A is -3. My H is 0. And my K is a +4. When I write my equation, because when I add 0 to x, it doesn't change it. It's just going to be in there by itself. And then on the back end, +4. Be careful, don't put that +4 under your radical sign. Okay, you have a homework assignment. in Schoology in Delta Math. Unfortunately, I had to create them, so it does not necessarily have videos that go with it. You can watch this video, or I did attach a video from the internet that explains how to write equations from a graph. I will see you all on Friday.